Hi, my name's Lee Swanwick. I'm Head of Domestic Circuit Protection for Electrium, and that includes Wilex and Crabtree consumer units and devices. This is a short video to answer a few of the most common questions we've been asked regarding AFDDs, arc fault detection devices. Why use AFDDs? What do the regulations say? What does recommended mean? What do arc faults look like? Arc faults on ring main circuits, on lightly loaded circuits, in brand new installations, and AFDDs in operation. So let's get started. Why should we use AFDDs? Arc faults in electrical circuits create heat and can cause fires. Arc faults can occur where insulation faults exist, for example insulation damage by penetration, cable abrasions, aged or failing insulations, which can expose the conductors and cause an unintended current path to exist. Arc faults are also caused by pressure, compression, impact, reduced conductor size, and by loose or poorly made terminations. There are two types of arc faults: serial arc faults and parallel arc faults. Arc fault detection devices detect and disconnect dangerous arcs to prevent fires. Government statistics show that over 13,000 fires each year start in electrical distribution or other electrical appliances. Circuit protection systems that use only MCBs and RCDs cannot protect against these arc faults that AFDDs can detect. AFDDs have been used in the USA since 2002, and in the last 10 years dwelling fires have reduced by over 5%. But electrical fires in dwellings have reduced by almost 20%. What do the regulations say? As we've seen, there are more than 13,000 electrical fires each year, and the fundamental principles of the wiring regulations include the prevention of electrical fires. So let's look at some examples that deal with this. 131.1 says in electrical installations, risk of injury may result from excessive temperatures likely to cause burns, fires, arcing or burning. 131.3.1 says the electrical installation shall be so arranged that the risk of ignition of flammable materials due to high temperature or electrical arc is minimized. 421.1.1 says people, property shall be protected against the harmful effects of heat or fire which may be generated or propagated in electrical installations. Harmful effects of heat or fire may be caused by failure of electrical equipment, insulation faults, or arcs, sparks, and high temperature particles. 422.1.2 says electrical equipment shall be so selected and erected that its normal temperature rise and foreseeable temperature rise during a fault cannot cause a fire. 421.1.7 says arc fault detection devices conforming to BSEN 62606 are recommended as a means of providing additional protection against fire caused by arcs in final AC circuits. Arc faults occur where insulation faults exist. Insulation damage by penetration, abrasion, aging or breakdown of the insulation that exposes conductors and allows an unintended current path to flow. Arc faults are also caused by pressure, compression, impact, reduced conductor size, and loose or poorly made terminals. Without AFDDs, can you be sure that you're meeting all of these requirements? What does recommended mean? It sounds simple, doesn't it? So we started with the dictionary definition, and it was no surprise to find that recommended means endorsed, commended, vouched for. To recommend is to put forward something with approval as being suitable for a particular purpose or role. But we didn't stop there. Believe it or not, there's a British standard on how to write the British standards. And there's expert advice and legal companies that specialise in regulations and similar documents. So we asked their advice too. And what did they say? Since 421.1.7 is phrased as a recommendation, designers or installers have the choice whether or not to comply fully with that recommendation. But any decision not to comply fully with the recommendations should be justified by the users of BS 7671, and the resulting degree of safety should not be less than what would have been achieved by full compliance with the regulations. AFDDs are recommended as providing additional protection against fire caused by arc faults, and therefore a compliant installation will either include AFDDs or other measures that achieve the same level of safety. If AFDDs are not used, the departure should be recorded in the electrical installation certificate as required under the general rules in Chapter 12, Regulation 120.3. What does a dangerous arc fault look like? So we've established that there's a number of causes of arcs. But in order for combustion to occur, we need three things: heat, air, and fuel. So let's take the example of a damaged cable. The cross-sectional area is reduced, creating a hotspot, and there's no stable arc at this moment. But the hot conductive material oxidizes and the insulation carbonizes. Heat increases. Eventually, the copper melts and gasifies, and sporadic arcing occurs across the carbonized insulation material. The arc then stabilizes and can reach temperatures as high as 6,000 degrees. This is not an arc fault. This is not an arc fault. And this is an arc fault. And this is an arc fault. Ring circuits. Does an AFDD operate on a ring circuit? Contrary to what you might have heard, arc fault conditions can occur on ring circuits, and AFDDs will detect and disconnect these faults. There are two types of fault: serial arc fault and parallel arc fault. Parallel arc faults can occur at any point in a ring main, including spurs and appliance leads from socket outlets. Serial arc faults can only occur in the radial connections to the ring, such as spurs, appliance leads, extension leads from socket outlets. AFDDs will detect arc faults wherever they can occur in or attached to ring circuits. A broken ring becomes two radial circuits. Serial and parallel arc faults can occur in these radial circuits. One of the most common questions we've been asked is about lightly loaded circuits. Are AFDDs suitable for both lightly and heavier loaded circuits? Yes, they are. It's a fact that many circuits will have varying load cycles, and at any given time, a circuit may be powering several appliances or luminaires or a single piece of equipment. There are two types of arc fault: serial and parallel arc faults. Serial arc faults can occur on lightly loaded AC final circuits, but the magnitude of the serial arc fault is relative to the load current and may or may not be sufficient enough to ignite the cable insulation. However, parallel arc faults can occur on any final AC circuit, including lightly loaded circuits, but the magnitude of the parallel arc fault is independent of the load, and it can generate enough heat to ignite the cable insulation. But the ignition of the insulation isn't the only consideration. Often cables are in contact with other combustible materials, and those materials may be ignited by either type of arc fault. Are AFDDs necessary in brand new installations? Newly completed installations should be free from defects, and there should be no cause for any of the protective devices, MCBs, RCDs, or AFDDs to operate. But protective devices are essential safety devices that are required for the whole life of the installation, and they're used to protect the users from the unexpected. AFDDs, just like any other protective devices, are used to protect people and property from the things that can go wrong when the electrical installation is used. A good example from the regs is the use of a 30 mA RCD. These are used as additional protection in case of a failure of basic or fault protection, and to protect against the carelessness by the user. RCDs protect users from electric shocks, MCBs protect against overload, and AFDDs provide additional protection against fires that can occur from arc faults in final AC circuits. Arc faults occur where insulation faults exist. Insulation damage by penetration, abrasion, aging or the breakdown of insulation which exposes the conductors and allows an unintended current path to exist. Arc faults are also caused by pressure, compression, impact, reduced conductor size, or by loose or poorly made terminations. When an AFDD is powered up, it runs a self-test function. With Electrium devices, this self-test function will be repeated every 15 hours. The integral test button can also be used to test the device every 6 months, as recommended by the wiring regulations. If the AFDD trips, the fault status indicator will show which type of fault has caused the device to operate. A single repeated flash indicates a serial or parallel arc fault. A twin repeated flash indicates an overvoltage, and a triple repeated flash indicates a residual current fault has been detected. Well, thanks for watching. I hope that's been of use to you. But just one final note. The Siemens technology that's used in Electrium AFDDs is already protecting over 5 million circuits. So if you need any further information, please contact us or visit our website at www.electrium.co.uk. Bye for now.